Hello everyone. Today I will present TermoAct, a thermal-aware vision-language action framework. Recently, vision-language action models have been widely studied. They enable robots to perform diverse real-world tasks. However, what if the robot receives a command, such as, "Hand me some warm water"? The robot can only rely on the visual information of the cup. To address this limitation, we propose a novel framework, TermoAct, which integrates thermal information. The VLM planner takes the user's task goal, images, and guidelines as input, and decomposes the task into multiple subtask goals. The VLA executor takes the decomposed subtasks as task goals and performs thermal-aware robot actions. Our experimental setup is as follows. The user's task goal is provided through an interface. For the VLM planner, we use the Gemini 2 Flash model. The planner analyzes the environment based on the task goal, images, and planner guidelines, and decomposes the task into subtasks. The VLA executor takes the decomposed subtasks, images, and the robot state as input for inference. The dataset used for training the model is shown in the bottom left. The proposed model can also perform everyday subtasks that are not related to thermal interaction. For example, grasping warm water in the current task is thermal-related, whereas picking and moving an apple is not related to thermal interaction. The proposed model was evaluated on 5 tasks. Task 2 involves handing over a cold cola. If a cold cola is not available, the VLM planner infers to provide a cup of ice instead. Task 3 requires selecting an appropriate cup, based on the target object. For example, if a tea bag is detected, the robot places it in warm water, whereas if a lemon is detected, the robot places it in cola. Task 4 involves identifying overheated batteries, among batteries moving on a conveyor belt, and picking them up. The final task involves turning off the power of overheated electronic appliances and organizing the surrounding area. These are the experimental results of the flat VLA model, which does not use VLM-based task decomposition, and the RGB plus RGB model. Thank you for your attention. If you have any questions, please feel free to contact me via email.